Welcome to YouTube channel scientific underscore math. We are solving a system of linear equation using the direct methods and in earlier lecture we discussed Gauss elimination method and the Doolittle method for solving a system of linear equation. Okay, so and we also write a Matlab code for the Doolittle method. I will provide link in the description of these lectures. You can watch it, and in this lecture we will discuss the Crout method to solve the system of linear equation. Okay, so we will decompose the coefficient matrix into the lower triangular matrix and the upper triangular matrix by the Crouts method. So let's start toward the Crouts method, and we will discuss what is Crouts method and the procedure of Crouts method, and we will also solve the example related to Crouts method. LU decomposition with Crouts method, and here the LU decomposition using the Crouts method is a method for solving a system of linear equation, and we write this system of linear equation in matrix form like that. This one is the coefficient matrix, this one is the matrix X, and this one is the matrix B. Okay, so we decompose the matrix in this method. The coefficient matrix square, okay, and the matrix A, coefficient matrix is a square matrix, is decomposed into the product of the lower triangular matrix and the upper triangular square matrices, where the diagonal entries of the upper triangular matrix is all are ones. Okay, so in Crouts method the LU decomposition has the form. Okay, so we decompose the coefficient matrix A into the product of lower triangular matrix and the upper triangular matrix. Okay, for example, we have n cross n equation, and we the matrix form of this one is like that. The coefficient matrix order cross n, we have this one. This is the coefficient matrix. Okay, so we have to decompose this coefficient matrix into the lower triangular matrix and the upper triangular matrix. Here we can see that all the entries of the upper triangular matrix in Crouts method all are ones, and in Doolittle method we have seen that all the entries of the lower triangular matrix was all ones. Okay, so and this is the general form of the LU decomposition, in which we decompose the coefficient matrix into the lower triangular matrix and the upper triangular matrix, and the upper triangular matrix has the diagonal entries all are ones. Okay, for the case of a system of three equations, the coefficient matrix of order, the coefficient matrix A is of order 3 cross 3, and the LU decomposition has the form. So this one is the LU decomposition of 3 cross 3. Okay, so this is the coefficient matrix, and we decompose into the lower triangular matrix and the upper triangular matrix of 3 cross 3 order. All are the square matrices, and now, okay, so and these are the low triangular matrix, and this one is the upper triangular matrix. We have to find out the values of L11, L21, L31, L22, L32, and L33. Similarly for the upper triangular matrix U12, U13, and U23. So to find out these values, first we multiply these two matrices with each other, and the product after multiplying the matrix we get this one. Now we will equate and the equations of this matrix to the coefficient matrix, and then we simplify the equation to find out the values of unknown. Okay, so here we now the solution is obtained by equating the corresponding entries of the matrices. Okay, first equate L1 to the A11, L11 is equal to A1. So the value of L11 will be equal to the A11. Next, equate this equation to the second A12. So L11 and U12 equal to A1. Okay, so in this equation we can set one the unknown value. We have to find this value U12. So we simplify this equation. U12 is equal to A12 divided by L1. Similarly, we equate this equation, and this one is the L11 U13 will be equal to A13 A13, and again we simplify this one, and for the value of U13, here we can see that we have to find out the value of U13. So U13 is equal to A13 divided by L11. Okay. So similarly, for this equation and for this equation and so on, for all these equation, we will equate with the entries of the coefficient matrix, and then we simplify all these equation to get out the values of unknown. Okay. So here we can see that you, here we have the value of this one is equal to this one, and u12 is equal to this one, and u13 is equal to this one. Now we again multiply, equate one equal to the this entry of the coefficient matrix, and this equation for equate with this one, and then we simplify this equation for the value of L22, because here L22 is the unknown. Okay. So after equating, and then we simplify this equation L2 to for 2 and this equation equate with this one, this entry, and here we have the L23 U23 is the unknown. Okay, we can see that. So we simplify for this one. Okay, so we will get the value of U23 from this equation, and next for this row we will equate, and L3 will be equal to A31, and be equal to this one to this A23, and we simplify this. Okay, so we can see this will be equal to this one, and okay, so this will be equal to this one, and we again simplify this equation for this unknown value, and this is the simplified form. Okay, so for generalizing the procedure for n class n coefficient matrix, we can find out the values of low triangular matrix by this form, and by this generalized form for the upper triangular matrix. Okay, so after obtaining the low triangular matrix and the upper triangular matrix, or the decomposition of the coefficient matrix into the upper triangular matrix and the lower triangular matrix, we apply the forward substitution and the backward substitution to find out the values of the system of linear equation. Okay, so now we discuss the procedure of Crout's method after decomposition of the coefficient matrix into the lower triangular matrix and the upper triangular matrix. What we will do in next steps to calculate the solution of system of nonlinear equation. Okay, so procedure, method for solving the system of linear equation. These are the system of linear equation in matrix form. And first step, we have the coefficient matrix is decomposed into the product of a low triangular matrix and the upper triangular matrix by applying the Crouts method. And after the decomposition of the coefficient matrix into the product of low triangular matrix and the upper triangular matrix, we replace this coefficient matrix with this one, with the product of low triangular matrix and the upper triangular matrix. Okay, so now we have this equation, and we have to solve this equation to find out the solution of a system of linear equation, or the solution of unknowns, and that is x. Okay, so x. Okay, so we solve this equation in two steps, and first we have the product of upper triangular matrix with the a matrix x is equal to some any arbitrary a matrix y of same order as the matrix x have. Okay, so next the low triangular matrix in subtree, the low triangular matrix is with the arbitrary vector y that is equal to b, and this one will be the equation 2. Okay, here we can see that to solve this equation 1, we have two unknowns, the matrix x and the matrix y. To solve this equation, first we have to find out the values of the matrix y. Okay, so for this one, uh, first we solve this equation, and after getting the values of the matrix y, we put this into the equation 1, and then we will find out the values of unknown x matrix. Okay, so now the solution x is obtained in two steps. The first we solve the equation 2, this one for the matrix y, and then the solution y is substituted into the equation 1, and to find out the to solve for the x. Okay, so here we apply the uh, forward substitution to solve this one and this equation, and then we apply over here backward substitution to find to solve this equation. Okay, so thank you so much for watching my video. Please subscribe my channel scientific underscore math, and in the next lecture we will solve example related to the Crouts method.